So this week we're going to talk about dictionaries. You guys remember last week we talked about lists. Lists allow us to store data in a data structure that can be called items, and those items inside that list can be of any data type. Could be lists, could be dictionaries, it could be floats, integers, Boolean values, could be anything in between there. Well, now we're going to talk about dictionaries, and dictionaries are similar to lists in that they store a lot of information for us. However, dictionary allows us to index those values. So if you remember in lists, they had an index, but it was a fixed value. It was a zero, starting at zero and went on up. And if you wanted to pull the last one in the list, you use -1, right? Well, it's handy if you've got fixed values and you know exactly their place inside that list. But what's not handy is if you have to go looking up, because then you have to go use the index command in order to go figure out what index it's in, then bring that information back. In a dictionary, we're going to use values for the indexes that we can easily recall or set up the way we want it. And so in dictionaries, they use what's called a key value pair. And the indexes inside dictionaries are keys, and the value that they represent is the value, a portion of that. So if we look at this dictionary, we have my cat equals, then we have the squiggly brace going down the back here. All right. This indicates that it's a dictionary. If you remember, a list is a squared bracket going down. The squiggly bracket is the dictionary. And we can say size, which is our key, and our value for size is fat. And then we have a key of color and a value of gray. Notice that it has the value or the index, in this case, the key, with a colon, and then it has the value, right? Then we have a comma. So we have a pair of information going in. We have the key, colon, value, all right? So all the keys out of here would be size, color, and disposition. The values in this one would be fat, gray, and loud. So what's handy about this is if we want to get the size of this cat, if we store, and I like to think of these as attributes, right? So we've got attributes of some thing. In this case, it's my cat. And those attributes are size, color, disposition, and then we have the values of those attributes. In this case, it's fat, gray, and loud. All right. But what's nice is we can use that just like any other index. So we can say my cat, and instead of having to know what place it is up here, we just call whatever key that we want to get back. So we say size, and it returns back fat on this side. If we want to use it inside of a string and use string concatenation, you can simply say my cat color, and it pulls back whatever color you stored it at. All right. Again, you can use any values inside of here, so that's also nice. In your list, you could only use integers as your index. In a dictionary, you can use whatever you want. So it could be integers, it could be strings, it could be floats, it could be whatever you want to be there. All right. Which means there's no order to this particular dictionary, right? If you remember a list, it's in an ordered fashion. It's considered to be an ordered data type. A dictionary is unordered, meaning there is no order inside of here. You just call the individual key that you want to represent and pull back. Okay. So if we look at the difference between lists and dictionaries, you'll have a list like spam equals cats, dogs, moose, bacon equals dogs, moose, cats. Notice that these two are not equal to one another, right? This one starts with cats, dogs, moose. This one is dogs, moose, cats. Those are not equal to the same. You'll get back false. However, if you have something that's scrambled like this one, no pun intended with the eggs, by the way. If you have a dictionary up here that has these keys, this one has the same keys, those will be equal to one another, even if they're out of order. All right. There is no order when it comes to dictionaries. All right. If you ask for something that doesn't exist, for example, if I call spam color, there's no color inside of here, you will get what's called a key error. And this is something that you can use with a try and accept statement in order to check whether or not something is actually in there. Okay. Let's see here. So if we look at this example here, what this is demonstrating is that you can organize your values in however you want. So in this case, if we do a while true, we say enter in a given name. We input a name. If the name is empty, then we're going to break out of here because we have blank to quit, right? If that name is in birthdays, aka whatever they typed in is in birthdays. Now, what birthdays does by default is it's going to check the keys. So if they type in a name and that name is in these keys, it will go ahead and return that value right here. Print, this is the day. Otherwise, it will say, I don't have the information for whoever you just typed in, name. What is their birthday? You put in the birthday and it goes ahead and stores that in the dictionary for you. All right. Notice to store that information, we don't append it. We just simply say birthdays, whatever index name we want is equal to whatever B day. All right. So you just say the dictionary, whatever key you want to specify, whatever value you want to specify. That's how you add to a dictionary. You don't have to have any fancy methods in order to do that. Anybody have any questions on dictionaries so far? All right. So if we look at what that program looks like, it says enter in a name, Alice. April 1st is the birthday of Alice. Then it says enter in a name because remember, we're stuck in a while loop. We enter in Eve. We don't have any information for Eve. What is their birthday? December 5th. And now the database is updated. So speaking of database, that's the reason I like to use dictionaries the most is they act like a database, right? So if you guys are programming in other languages, you know, the databases can be a great way to store information. It also functions in a key value pair type story. But in Python, we can use dictionaries, and it's a great, fast way to deal with information and store information so we can quickly and easily retrieve it. All right. Let's see here. You don't have to worry about that. So there are a couple methods that are associated with the dictionary. All right. If we have spam equals, and then we have this dictionary. If we want to see what all the values are of this dictionary, we can use a for loop for saying for v in spam dot values. This dot values is the key part. Print v, and it will go ahead and rotate through each one of those and print out red and 42. Right? You can specify v here. You can put whatever you want there. It doesn't matter. Right? V makes the most sense because you're talking about values, but you can literally put whatever you want there. Okay? Just a variable name when you're going through this for loop. All right. In this one, we're going to be checking for all the keys. So for K in spam.keys, print the keys out. That works. The last one is .items, and .items will allow us to get a tuple back in which the key is the first item and the value is the second item inside that tuple. All right. In this case, we said for I inside of this, therefore we're going to get back the entire tuple. We can also use the multiple assignment trick, which we'll talk about down here, in which case we can say for K comma V in spam.items. Well, then it assigns K to the first value. In this case, it's this first part here, right? Color. And then the V in this case is going to be whatever the value is, in this case, red. So that we can easily just use a print statement that uses K and V. It's much easier to remember than having to split everything out, right? So if you just want all the keys out of a dictionary, you use .keys. You can also omit .keys and not put the .keys, just say for value in spam or just for V in spam. It will assume you're talking about keys, right? If you want the values, it's .values. If you want the items, it's .items. You typically want to use something like this for the items one, in which case you assign K to the key, V to the value, and then you can use those to print it out however you want. Anybody have any questions on that? All right. If you just call spam.keys, that will return what looks like a list of those values back, and it's just all the keys that go through there. But this isn't truly a list. It's what's called a dict keys object, all right? And with that dict keys object, it looks a lot like a list, kind of functions like a list, but doesn't have all the power of a list. So if you want to convert that over so that you can do something to it, you need to call it with list and then put spam keys inside of that list function, which will then convert it fully over to a list. This will allow you to sort things in there. It'll allow you to do other things that you may normally do with a list. Everybody kind of see that part? That'll be the most useful part that you guys will do within dictionaries, is being able to sort all the keys that come out of it. So say all the keys were names for whatever reason. If we wanted to sort those, because remember they're unordered, we could pull out the dot keys. We would convert that to a true list. And so if I said something like, let me pull up idle here. Let's just steal this spam here. All right. And if I said something like my list equals list of spam.keys, that will give me back all of those keys, which will be color and age, right? And if I want to sort those in alphabetical order, how would I do that? You have something like mylist.sort, right? That will then sort whatever I got back for those keys in alphabetical order. Now I could do a simple for loop for item in my list, print item. And those items will print out in alphabetical order. So let's take a look at it. And you'll get age and color in the right order, right? So here we had color first, then age. Again, there is no true order inside of a dictionary, but if we pull it into a list and then we sort it, then we can get them out in alphabetical order. We could do the same thing with values if we wanted to do that too. So if we plug in values here, and then we run this. In this case, because we have a string and an integer, we cannot just sort on those, right? Does everybody remember that from sort? We cannot sort anything that has two different data types. It has to be the same data type. So it won't work with our particular dictionary that's here. Okay. All right. Let's see here. So we have that. We have our dot items, in which case we can print that out in that fashion that we talked about before. If we want to check to see if something exists, whether it's a key or a value, you just use the in, just like you guys did before with the list. So you would say is name in, or in this case, if name in spam.keys. And if that's true, then we get back true. If we say dot values, we can check those. And we can also use not in if we wanted to use that as well. All right. It's handy with your if statements when you're checking something. We also have what's called the get method. The get method is going to try to find whatever you pass it the first one. If it does not find it, it has a default value that comes back to you, right? So in this case, we're saying, go find me cups in this dictionary. And if you find cups, return whatever the value is. In this case, it would be 2. If you don't find cups in the dictionary, then return 0 for me. So for example, here, we do not have eggs inside of our dictionary. Therefore, it returns 0. And when it prints this out, it says I'm bringing 0 eggs. Everybody see how that works? The benefit of doing this is that if you write it in such a way that you have just this, where you say picnic eggs, but eggs doesn't exist, you're going to get an error, right? You'll get a key error. Instead of writing a try and except around it, you can just use .get, and it will look for it. If it doesn't exist, it will return back whatever value you tell it to return. You also have the option of set default, which you guys want to pay attention to this. This will be on a quiz or a midterm. Set default has the ability of doing this code here, in which case you have this dictionary. If color is not in spam, aka spam.keys, right? We do not have color in spam.keys. Then it's going to set spam color equal to black. Right? This is multiple lines of code where we can do that in a one-liner of spam.set default. We look for color, and then we tell it what to return and what we want to actually set it to be. So that's the difference between set default and get, right? Get will go look for something and return something else if it doesn't exist, but it does not change your dictionary. Set default, we'll say, okay, that doesn't exist. Go ahead and set the value, and then we'll go ahead and return this new value. So here you can see that the dictionary added the color black inside of there. We could also look for color white, in which case it's going to find color this time and return back black. So we're not going to overwrite it with white. Everybody understand how set default works? To set a default so that you don't have to call and set it up. So say you are looking for Alice. If Alice doesn't exist, go ahead and set a value for her of 0 in the age group or something like that. So that you would update the database. You would actually at least store the name at that point and put a value in there. Yep. That's a rough example, but that would be a good reason to use it. The idea is that you don't have to do these multiple lines of code if it doesn't exist. In this case, it looks like you're saving 3 lines of code. You're actually saving more and bigger functions and things like that. Great question. Okay. Let's see here. I'll print that out. Okay. So in the past, you guys have been printing out lists, right? And how do I tell you guys to always print lists out? Anybody remember? For loop, right? Exactly what I have right here. So anytime you have a list and you want to print it out cleanly to the screen, we always use a for loop in order to print that out cleanly. For a dictionary, you can use what's called pretty print. And so if I say import pretty print, which is just p print, then I can call print just like I would before, pp print. And then you just pass in the name of the dictionary, so spam. Now, when I run this, it's not going to look that fancy because I have a very small, this should be keys. Go. So when I pretty print this one, it just prints out the entire dictionary. And in this case, there's no different than me running that one versus running print spam, right? You'll notice it's the exact same. Okay. Other than we added, or we flip-flop these two around. Notice how one I printed out with pretty print, the other one I printed below it. Notice when you print it, it does not have an order, right? Remember, this is unordered. So one time it'll print it this way, the next time it'll print it this way. Just know that there's no order. However you call it, it may print it one way, it may print it the other. The benefit of using pretty print in this case is if you have a really long dictionary with a bunch of stuff in it. So let's say something like name is Jason. Let's do team. We're gonna have to throw in Chiefs after last night. Sport, football. Class, Python, grade A. All right. Now, if I run this and try to print that out, notice how it prints it out nice and clean as it goes across here, right? Does anybody else notice what it does? So this is what would have happened if we just print it. What does pretty print do when you do it in this fashion? What's that? It actually does, right? So you'll notice that it goes with the A, B, C, D, and it does it in alphabetical order for you. But it also prints it in this nice clean column so that you can see your keys and values in a nice clean area. Now, in this case, I have very short things, but if you had, say, an entire question in there or you stored a very long string in there, it keeps it nice and clean as it formats it down. All right. However, when you guys print these in your projects, don't use pretty printing in order to print them out. Use a for loop to print those out. So it will look like this. If we wanted to print out each one of those values, instead of using pretty print, we would say for K comma, V in spam dot items. Remember, that gets us back that tuple. Then we can say print. In this case, it's going to be K. So let's do K plus, better convert that over to a string just in case we got something we don't normally have. And let's put a space or a colon space in there. Let's do a string of whatever our value is. Let's print that out. You'll notice it'll go ahead and print it out in a nice clean fashion here, but it does not actually dump the dictionary to the screen, right? It's also not sorted as it goes down here. So that's fine. We could have a way of sorting that if we wanted to. How could we sort this in order to print those out if we wanted that in alphabetical order? Based on what you guys learned up here. Well, we know if we do this little sort trick up here, we get every one of those keys in alphabetical order, right? So what we could do is just do a lookup based on this my list that we have inside of spam. We could say for item in my list, print, and then here we just do a lookup based on that item, right? We know what the key is because that's what's stored inside the list. We could say spam and then whatever item is. And that will get us back our value. We want that on the right-hand side. So let's leave that here. Let's go back to item plus, and then we could do a nice little colon space, spam item. And then we can go ahead and close that off. So what's that mean? We're going to take whatever item came out of our list. In this case, the first one's color, age, whatever, but we already sorted it using this sort part. Therefore, you're going to get age back first. It grabs age out of the list. It prints age, does a colon space, and then does a lookup inside spam to see what the value of age is. In which case, it's going to grab 42 out of there, right? Now, what's the problem with what I did here? Will this run? Somebody said no. What's that? It will get, yeah, string, right? That's the problem is like I did down here. I need to make sure that I always convert them to strings when I use them in a print statement. Thankfully, here in about a week or two, we will be able to show you a way not to have to do that. But right now, that's what we got to do. So we can convert those over. Therefore, if I run this, I will get the proper output, age of 42, class, color, grade, etc. Whereas opposed to down here, it just does it in whatever order it wants to. All right. So if we take that one out, run that. Now you got them in alphabetical order as it comes down. Everybody see how we got that? Hint, hint, wink, wink. That might or might not be a huge problem that people miss on homework assignment 3. Okay. So once you get a dictionary the way you want it, if you want to print it out in its alphabetical format, go grab all the keys, put them into a list using the list function, do a sort on it, and then do a simple for loop to print those out in the right order. Okay. But pretty printing is very, very handy when you guys are troubleshooting. So you're in the middle of a project, you're just trying to see what's in that dictionary. You know there's a lot of values in it. Just use pretty print to dump it to the screen so you can see what's in there. If you're going to be printing it out to the user, then make sure not to use pretty printing, just use a simple for loop. And there may be a reason to put it in alphabetical. There may not be a reason to put it alphabetical. It doesn't matter. Just depends on what you're trying to print out. Okay. So why would we use something like a dictionary? What's handy about that is it allows us to do data structures of real world things. So for example, I got a chessboard here, right? If I want to figure out what this coordinate is, that is D in the column, and it is in row 4. Therefore, this spot is D4, right? Well, if I had a very large dictionary, I could store where each one of these particular items are. So if I look at 1H, that value is taken up by B king, or the black king. If it is in 6C, then is the white queen. 2G is the black bishop, etc. So we can recreate this board at that point. If we don't have that key inside of our dictionary, what does that mean? If we're looking up a particular space and it's not in this dictionary, so for example, if I look up B4, it's not going to exist in here, right? Which means it's, don't overthink it. It's empty, right? If I'm looking up B4 and it doesn't show up inside my dictionary, that means it's empty. So if somebody says, I want to move the queen over to A4, right? I don't think that's the queen. I think that's the king. C6, 6E. Yeah, that's queen. We're good. So I had the icon mess me up there a little bit. If we want to move that down here to A4, then we could check to see if A4 is already in our list. If so, what would that mean if something was already there? Does anybody play chess? Know how this works? Yeah, they would take it, right? If it was a black particular item, they would have to check to make sure it starts with a B. And if it starts with a B, then that means they could take that particular piece. All right. So you can use dictionaries to recreate certain games. You could use it to recreate coordinates. If you guys are building fancy tic-tac-toe boards, you could do the same thing, right? So in tic-tac-toe, this is top left, top middle, top right, middle left, middle right, etc. So if we wanted to build out a tic-tac-toe game, this is what the board would look like, where the key is the position and the value is what's ever currently in there. So when we ask the user to place an X, then it would look something like this, where we put an X inside that blank line, and this is what we would see. Now, granted, we're not going to get this fancy little tic-tac-toe board like this, right, as a graphic, but it would actually print it out in a nice form fashion if you guys follow this. So for example, if I steal this code here, which prints a tic-tac-toe board, and then I call that, so we call print board, right? And we need to pass in the board. So let's do board. And that means I got to go grab board, which is this thing here, the board. So let's set that value, and this becomes the board. So this is our tic-tac-toe board. We're going to pass those values into this print board function, which is going to print this out nice and clean. And if we run that, we get a tic-tac-toe board. All right. So how does that work? Well, we just print the value with a pipe symbol, and then we do the next value with a pipe symbol, etc. Then we print a nice little dash plus that gets us this nice little line. And then we just need to print a value inside. Notice how we're storing an empty space inside of here. If I take out that empty space and try to run this, that was actually a horrible example to do that at the end. Nothing changed, right? Put that back, steal one of the other ones, this guy. Well, now our tic-tac-toe board looks all messed up, right? So the idea behind these empty spaces is that it spaces everything out accordingly so that when you print it, you'll see the right value. And if we wrote the functions in order to say put an X in mid-M, aka if it is empty to a blank space, now we're going to put an X in there. We run this. We get an X back in the middle. All right. So if you follow these instructions on how to make a tic-tac-toe board, you would see how that would all work. And you would have to add additional functionality, right? So before they go to their next turn, in other words, if we just steal this current tic-tac-toe game, and we look at that code, we start out with this, the board up here. Remember that when you have a dictionary, you can align everything that goes down here. So we can just do this one like that. And that's great. They're all aligned with all the values empty. Well, that doesn't quite work out the best for a tic-tac-toe board. So it'd probably be better if we did something like this one, where all the tops were on a line and then all the mids were on a line, so that we could better see what our tic-tac-toe board looks like. Like that, right? Now we have the function that will print the board out for us no matter what's in that value. That's all this does, is print out the board. We say that turn is equal to X because X goes first in tic-tac-toe. And then we can say for I in range, let's get rid of this stuff here. Copy over very well. There we go. So for I in range of 9, why would we do range of 9 here? If you think about tic-tac-toe, what significance is I of range of 9? 9 spots, right? So that means that there is only a maximum of how many turns? 9, right? So that's why we put them in a for loop of 0 to 9, which means 0 to 8, right? We're not actually using I. We're just trying to get them in a loop that only plays through 9 times, because that's the maximum amount of turns they could have anyway. So we're going to print the board to the user. We're going to say whose turn it is and what space they want to move to. They have to type in what space they want to move to, right? So they have to type it in this case, very specifically, low-L in order to go to lower left, right? If it's X's turn, right? If turn equals X, then now turn is equal to 0. Else, if turn is equal to X, right? We don't have to write if a turn was equal to 0 because it's either X or 0, one or the other. This just allows us to change turns between the two. So we could throw a comment, change turn. This one here sets value in dictionary. And then here, this part is going to gather get move from player. Okay. So if we run this little trick here, of course, there's an indent issue. There it is. All right, we got a tic-tac-toe board. Turn for X. What space you want to move on? Let's say low left. Of course, I hit my button wrong. Sorry about that. Didn't find it, right? So let's try it again. Low left. There you go. And it put his O in the bottom. Now, what's the problem with our game? And we just saw it here, right? Anybody see the problem with our game? Yeah, if we type in something and it doesn't exist as an actual key up here in our dictionary, it just continues on and automatically changes the turn. So how would we rewrite this to make sure that that particular spot exists inside of our dictionary? Well, first, let's go ahead and throw this in a while loop where we actually get their move, right? So while true, let's get their move. And then we can just do a test. How would we check to see if that exists in our keys up into the board? If whatever move they have in the board, which is going to check to see if it's in the keys. If it is, go ahead and set our move and continue on, right? So we could take this code, move it out. That. Elif, in this case, we just want else, print. Let's go ahead and break out of this, by the way, if we actually do have a move. Print. That is not a valid move. Please try again. Okay. So one little tweak there is going to make sure that our program that they type in at least a valid move, right? So we have low dash L. All right, now X is down there. Now we can specify for O. Same way it's going to check. We go mid M, and we can see it's there. And of course here, if I do mid L, and on the O, I do top right, and then X comes in and we do top left. I got all three in there, but it keeps going on, right? So what kind of functionality would we have to put into tic-tac-toe now? Yeah, we got to check how they win, right? But what kind of checks would we have to look for? Well, it's tic-tac-toe. Is X in all the tops? Is X in all the mids? Is X in all the lowers? Is it top left, middle left, lower left? Top, mid, down. Then we have to do the diagonals. Top left, middle, 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 mid, mid, middle, and lower right. So we would have to write every single one of those possible answers in for X and every single one of those possible answers in for O to see if we ever get three in a row. It sounds complicated. It's not. We just have to write some functionality to do that. Right? What's also kind of a pain at this point in the game? How did I know what to type in to get that particular spot? I don't, right? There's like nothing that tells me that's what that is. So what we could do is we could build out something that would print a special board. So we could say move board equals, then we'll go ahead and steal this, the board. And then we could put this value right in here. So we could say top left, something like this. Then we steal what's over here. We put it in here. The idea is it will print out all the moves for the user inside of there. Let's take a look. All right, let's print out our intro a little bit. So let's do something like print Jason's spectacular tic-tac-toe. Okay, print. Here is the move board. Then we just print that move board, which means we're going to call print board and pass in all the one that has the moves. So move board. Say print. Let's begin. Then we can go through here. So if we look at this, we got a little more well-rounded program. We say we have tic-tac-toe. Here's the move board. That move board looks horrible, right? So instead of having to have the user type every single one of these, which is also not that great, what's another way we could do this? Numbers, right? Real simple. They could put in the spots and we could go from there. So if we go here and do a 1, and let's just assume that we're going across here. So 2, 3, 4, 5, 6, 7, 8, 9. All right, let's look at that when it comes up. Hey, that looks better. Of course, let's go ahead and throw some spacing in here so that we're not printing on one another. Remember, there's better ways to do that, which we know now, but that's okay for now. There we go. So there's the move board. Let's begin. We start out with our blank one and move on. Now, the problem is yes, we told them what moves there are, However, we got to build the functionality in, right? Because when we type in 1, it doesn't have a clue what that is. So how would we do that to where we could check what they type in? And if that is that, then that equals something up here, right? Can we look up a dictionary by its value? How would we do that? For just 1, 2, 3, 4? That sounds like a whole lot easier, right? So let's do that. You'd have to have 1, 2, 3. See, now that's a smart programmer because that's a whole lot easier than the path I was about to take you down. However, I do want to take you down the other path just a little bit. Because what if you can't change those around for whatever reason in your code? Notice I actually have to update quite a few lines in order to make that work for what we're looking for, right? So I got to change every single one of these to look at that new functionality. If I didn't want to do that, what would be another way of doing that? Whoops. Get back to where I was here. I took too much out. There we go. Well, what we could do is we somehow need to get where these are flip-flopped, right? That way we can do a lookup in that. So we could call this something like valid board, right? And we need that to equal the flip inverse of this dictionary. So how would we go about creating valid board in order to get that? So we'd start with an empty dictionary. And then once we have our valid dictionary, how would we loop through this particular dictionary? Everybody remember, like if I wanted to print this out, how would I do that? Be a for loop, right? So for k comma v in move board dot items. All right. We're going to grab k, which is whatever this thing is up here, right? And we're going to flip it over to where it's v. So in other words, we would say valid board, and we would put in our value now, which will become the key of our valid board dictionary, is equal to k, which is now the k value or the key of what move board was. All it does is take those two around and we flip-flopped it. We assign the key to the value of what was ever over here. So now that we have valid board, we can do any kind of lookup we want inside valid board to say, is that valid? So if move in the board 1, we want to check that because that tells us if it's not a valid one. And then elif, let's say if move in valid board, and what I really want to do is if the move is in the board, right, which tells us that that's a possible one up here, which we need to invert that before we can ever do that. So we would say if move in valid board, right? If it's valid, which means they type in 1, is 1 actually a key now in this valid board? Should be. So if it's 1, then we need to get the value of it, and that is now what their turn is equal to, right? So we would say something like move equals valid board move. Or in this case, turn, sorry. Not turn. What'd they type in? They type in move. And we're going to reset that to whatever it was before. Yep. Okay, so now that that's our valid board, now we can go in and check to make sure that it's actually in there. In which case we can just set it. If move in the board, then we went ahead and set it before, right? So we had the board. Equals turn. And that's how we put our X and O's in there. So let's just see what that does for now. I'm sure there's more we need to tweak in that. Also works if I put this in the right order here. There, print. We also need this one if it is not here. All right, I know I left pieces out of there. Let's see what I left out. All right, so we have a move. I put A, SDF. That's not a valid move. If I put a 1, now it says turn for X and it does nothing, right? So I need to break. Let's do it again. Let's do a 1. And it put it up in that spot like we anticipated it to, right? But what happens if I tell this person 1? And just override X, right? Even better. Great way to play tic-tac-toe. All right, so we got to at least have a check to see if there is something here first, then we will go ahead and set it. So if move in the board, and we can say if the board move is equal to what? In this case, just an empty space is what we have it designated, right? If it's an empty space, go ahead and do this and set it. Else, we come back to print. That's not a valid move. So we're going to redo this whole line. Something like that. Run, run, run. All right. So we got 1 for X. We say 1. That's not a valid move. And we go back to pick something else. They put 2. Now it's back to X and we go. So you start out with a really basic tic-tac-toe game, but then you actually start adding the functionality of tic-tac-toe to make sure that it fits the restraints within the game itself. So our next step would actually be building out the winning ways of tic-tac-toe, which means we would probably want to store that in a dictionary to see if that's a valid way of making that move. Right? There's a lot of different ways to do that. If you were assigned that, how would you guys do that? Let's call something like win X, right? And what are all the possible answers that they could use to win? Based on what we have up above. So we'd have something like top L would have to be set to X, right? We'd also have to have top L or top mid is equal to X. Top right is equal to X. That's one possible way they would win. Yeah. You could, right? But then we would have to write whatever code that we did to do the check to go ahead and flip that for us as well. So it would just be an extra line to have it go back and flip and see if it's a valid move. And if it is, then pull it and go. In this case, we know they're going to be valid moves, so we can just pull it in directly. And because we're really just checking to see if the board equals whatever our win board looks like, that makes that a little easier too. We don't have to flip-flop it at this point. So say this is just one option here, right? We'll put win x1. Then how would we write it to check to see if they won? And we would probably do that here before we change turn. So check win, right? And on the check win, we want to know whose turn it is. So let's pull in turn. And we won't define that function inside. That's a horrible thing to do. Don't do that. We want to always define our functions at the top. So let's do something like def check win. And we're going to take in whatever the board looks like. We also need to know whose turn it is, which that we can get as a global variable, right? We can also pull in the board as a global variable if we want, so we don't have to pass that in. So on a check win, we could say if, what would it look like? Let's just check X win 1 for now. Well, we could loop through X win 1 to see if that's going to do what we would expect it to be. So we could say for K comma V in the board, or in this case, let's do win X. All right, so what that does is give us back a tuple of this and this, this and this and this and this. And then we could say if the board K equals V, right? That would check to make sure that top L is equal to an X. And if top L is equal to an X, then what? If the board, we'd have to kind of keep some kind of counter system, right? Or some way of doing that. There's a million different ways to answer this one. You just have to figure out how you would go about labeling that. There's also a couple ways. You could just take the whole board, write this out as X, right? And then just say, is this board match win X1 board? So we could just say this, copy this one. This is win X1. And we could just simply do a check inside of here on our check win. If the board equals win X1, right? And if that wins, then we know X1. The only problem with that is we're going to not have some O's or something like that over here. It's not going to magically align at those at the top. So we would have to pull specific values to see if they would be X's. So a better way of doing that would be if the board top L, right? Let's just grab this one. Equals X and the board top L. So we're just going to repeat this. And in top L, we would have something like top mid and top right, right? So now we're checking to see if those values are all equal to X. And if so, print what? X wins, right? Something like that. We could also, instead of printing X wins, we could return true. And down here on this check win, we could say if check win, which is going to return either true or false. If it's false, then we go ahead and change our turn and do all that. If it's true, then we could say whoever's turn it is, because we know whose turn it is. We could say print turn plus wins. Right? So that's coded in a Pythonic manner that we don't need to print all the X wins, Y wins, or O wins, etc. We just take whoever's turn it is, say they win, and at that point we can break out of the game, right? If it returns back false, we just continue on down here and change the turn and go on. So we have return true. What's another one we would need to check? All the middle ones, right? So we would need to say elif the board, whoops, something like this. And this would be something like mid. And then we can copy this one, say and that here. And let's change this to M, to R. And again, if that works, go ahead and return true. What's another possible combination? Obviously across the bottom. So we're going to steal this one. It's a lot of code, but it's easy. It's really just copy and paste. Okay. So we've got the lines going across horizontal now. It's going to check those. What's the other way we need to check? Straight up and down vertical, right? So LF, the board. This would be something like top L equals X. And let's see, it would be mid L. So let's steal this one. And low, steal that one. Okay. That gets us the first column. Second column, there again, you can just start copy and pasting. It'll work. And the last column, okay. So we've got our horizontals, we got our verticals. What's the other ones we got to check? Our diagonals, right? So we would have something like the top X. Mids. Woo. And then we would have our other diagonal. Okay. So that would return true. What's the problem with this? What's that? Got to do all the O's, right? How would I check that? I have to copy and paste the whole thing, right? What would be an easier way to do this so I wouldn't have to copy and paste it twice? You think about your Python. We're checking to make sure that it is value to what? X, right? We're assuming we're X, but we know whose turn it is. So what if we just pass the turn into here? So we know whose turn it is. And instead of checking for X, we check to see if it's equal to the turn. And if we do that, now we don't have to rewrite that all for O. We don't have to write it for X. We just do one simple check to see if it's whoever's turn it is. If any of those matches, they win. Else, we return false. We don't have to write a whole bunch of extra code. It's already bad enough we had to write this much, right? But that's all the possible outcomes on the board. So who's ready to do chess? That was a joke, right? Nobody wants to write chess. There'd be a lot of checks to see who won and who took what, right? That was actually a question. It'd be a lot of checks to see who won, right? Who plays chess? Nobody play chess? How do you win in chess? Check, right? But the idea is you got to get checkmate, right? So all we have to do is check for one piece out of that chessboard. If the king is in this particular range, then they win. So it's actually less checks that you would have to do overall. Because as long as that king, because that's the only piece we have to check for, then we're good. Okay, so we got all these turns. Turns look good. Let's come down here, do a check win, pass in our turn. And now we can see whether or not that person wins or not, right? Otherwise, what we would do up here is do an else and return false. In which case the false will kick them back here, change turns and go. So let's see if our game works now. Oh, I didn't see the chats there. The last one should be low M. Did I fix that or did I mess that up still? Sorry about that. I didn't see the chat pop up, Bo. Aha. Did this one? Top, mid, left, middle, 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 right, right. Oh, this should be right, right? Now you got me thinking everything. I didn't fill these all in, did I? Top, middle, right. Okay, there's top. There's middle. Yeah, these need changed. And R. All right, and then going straight down, top left, left, middle, middle, middle. Right, right, right. LMR, this should be right. Top right, middle, lower left. Okay, good catch. All right. Which is why you always go back to your program and see if it actually works. Oh, we have X's in there. Let's take out our stuff that we had up here. Otherwise, I'm picking X for that game. Okay. So one, we have one again, says that's not a valid move. So we got to pick another one. Let's do three. Okay. Let's see, 4 and 6. And what is that? 7. I hit 7, X wins, and we go. So you've successfully written tic-tac-toe. Congratulations. Course is over, right? All right. So I used the full-blown tic-tac-toe in this example, which I've honestly never done before, because I don't want to see tic-tac-toe on midterms. Please don't submit a tic-tac-toe. All right. 100 students a semester, 75 students a semester. Everybody submits tic-tac-toe. I can only play tic-tac-toe so many times with myself. All right. Now, if I built an AI, I could have the Whopper. Anybody know what the Whopper is? Sweet. I am definitely from the 80s. All right. That was War Games. They played tic-tac-toe and they were going to launch missiles at each other. That's your homework for this weekend. Go watch War Games. Okay. Matthew Broderick. You guys go back and watch War Games. Okay. Does everybody kind of understand dictionaries and how they work? That's the whole point of this, is that you can see how dictionaries function in here. You have keys and you have values, and you can store coordinates in there. You can store all sorts of stuff in there, and then you can start to build the basic foundation of simple games. All right. So don't use tic-tac-toe for your midterm exam. And if you do hangman, please make it your own game. but there's lots of other stuff you could be doing for your midterm exam or midterm projects, thus your final projects. Okay. We look at the rest of dictionaries here. It's going to show you how to do nesting. Again, you could do nested inside of that. So Alice is now bringing apples and pretzels. Bob is bringing ham sandwiches, and it gives you the count. This is handy because then we can print out this nice big loop that will say who's bringing what, and we can do counts to see how many of those things that are being brought. All right. At the end, what I'm getting you to do here is go play with some of these practice projects, particularly this one here, this fantasy game inventory. It's good to play with that one because if you guys end up doing a fantasy game or something like that for your midterm or a text adventure game, this is exactly how you would build out the inventory system for it. All right. So if they have to go pick up the golden torch or something like that, you can build out the inventory so you can check to see if golden torch is in there, that kind of stuff. This works out really well for people that are trying to do that for their midterm projects. All right. The only way you're going to get good at the lists and the dictionaries is to practice them. So try some of those out. It's required on your midterm project and final project that you use examples of lists and dictionaries. All right. So you got to be able to use those inside your code for a given purpose, depending on what it is. All right. I'll stop the recording.